Hey, I'm Hannah May, and this is my chapter reaction video over chapter 8, and this chapter is called Energy from Earth and the Moon. Overall, in this passage, we just talk about like renewable energy sources, and we mostly talk about geothermal and tidal energies. We learn that geothermal is very reliable, and of course, it's more friendly to the environment and better for the environment and more eco-friendly. So it would be a good switch, but we'll talk about more of that later. But also, we know that the geothermal cannot provide enough energy to meet the demand globally. Then we learned that some heat pumps actually run off of geothermal energy, but they're very costly and very expensive to install. We'll also talk about more of that later. And then we talk about tidal energy and how it's called like it runs off of the tides in the ocean. And all these the tides based on the gravitational pull from the Earth, Sun, and Moon, and it just causes the rise and the fall of the tides. And basically, just overall, both of these energy sources are better for the environment, especially over fossil fuels. The first section that we get to is called the geothermal resource. This one just talks about geothermal energy and how it's a continuous resource and how it's very reliable as well. It's more, of course, we know it's more environmentally friendly, like I said, and it is very consistent and it can give us consistent power. Excuse me. Um, but overall, it cannot generate enough energy for the overall demand for energy that we have as humans in the world. Um, it just can't suffice that demand is too great, too big. Like I said, it's very reliable and consistent, and it's very much a lower quality and diffused compared to solar energy and wind energy, hydraulic, all of those other energies that we've talked about. Those energies really rely on um, the weather, and this one's more consistent and reliable than those. I don't know, really, that's insane how they can get power from within the earth. But like I said, it can't meet that demand, which brings me to my first diagram. This diagram I chose because I liked how it showed all of the different places in the United States, all the different states, and like the colors show, I mean, it's self-explanatory, like the red, orange, yellow, and green. They show the places that have the most geothermal gradient, which is just like heat from within the earth. And from this, you can see that in the western states, it's way more than over here in the eastern, per se. Not really sure why, but that's kind of cool. It's insane how like it's different from the other states. Then it brings me to my other one. I just liked both of these because I thought they really went with the chapter and helped me better understand it fully. And this diagram just talks about geothermal. It shows us a geothermal power plant and how it is used and how it uses steam from like vapor dominated systems, which was one of our vocabulary words. I liked how it showed and just demonstrates everything and how it goes through and back and it gets from the ground. I just thought it was a helpful diagram. This brings me to my next section called Geothermal Energy and Technology. It talks about how it's just a valuable energy source for us humans, and it has been for years. It's been used throughout history. Historically, it was really mainly used for like food preparation and bathing. And to my surprise, I had no clue this was even a thing, but it was used to build spas. I don't know why they would need it. They needed spas back then, but I guess props to them. Um, then we talk about how it can be applied in so many different ways. It can be used in just individual buildings, or it can be used in bigger industries, or like a whole community. Basically, it just it just requires lower thermal energy. The hotter the geothermal sources, they can be used to generate electricity through a vapor dominated resource. I thought that was cool. I don't know how they can use steam and turn it into energy, like they can turn the lights on like we all have. Um, the next section is called, it just talks about the impacts. It's called environmental impacts of geothermal energy. And it just talks about how, of course, everything is going to have an impact on the environment, no matter what it is, what we do, what we try. It's all going to impact something, some way, or somehow. But obviously, this type of energy has a less negative impact on our environment. Fossil fuels has a really bad impact that we've learned about for the past little while. These geothermal plants have really low emission rates, which is just like less carbon and sulfur and dioxide, all of those things, especially in comparison to coal plants. Um, we learned that binary geothermal plants are negligible carbon emissions because of their closed loop systems. We talk about those a little bit later as well. Binary geothermal plants we actually learned about and how they're used in our vocabulary. Um, these binary plants used to cause really bad water pollution, but of course times have evolved and things have gotten a lot better and newer and technologies have evolved. So therefore, they have come up with solutions to try to help reduce this water pollution, and it just uses like hydrothermal, keeps it all in a hydrothermal system. It's explained in the chapter. These could cause land subsidence and even small earthquakes. I didn't know that geothermal energy could cause earthquakes, but I guess it's because it comes within the earth, so it's like messing with the earth's whole thing, I guess. But also, it could be disruptive to those around these plants, and because they're really noisy and just annoying to be around, I guess. Which brings me to my next one. It talks about the heat pumps and the different types of heat pumps, and it just talks about how there's so many different types and how they function in both heating and cooling settings, and how they use geothermal energy, air, and even water from the surface, from bodies of water on the earth. In the cooling mode, it just takes the air from in the building and takes it outside. Uh, in the heating mode, it takes the energy from outside and puts it into the building. So, so yeah, that's I thought that's cool. How that it's different from cooling and heating. I didn't know that was a thing. There's different types of heat pumps that we've learned about this week, especially in our vocabulary. We learned about geothermal heat pumps and air source heat pumps and how they're used different. Geothermal heat plants, they actually include both closed and open loop systems. Um, then we get to our next one, which is that little box, the science meets policy, and this one's called geothermal incentives. We all know what an incentive is. It's basically just they offer you something to make you want to do the things that they want you to do. This section just basically shows like the more of the financial sides of things and how the United States federal government actually offers incentives to individuals and even individual states, but just because they're trying to encourage people to switch to geothermal heat pumps, but they're very expensive and costly and just hard to get put in because of the cost. They are very expensive, but they're very expensive because we have to drill the wells and or they have to lay pipes underground. And but overall, I mean, even though they are costly, they are very much more energy efficient, and the better way to heat buildings. The U.S. actually provides different tax credits for these heat pumps, and of course, these credits have been evolved and uh, changed throughout the years. And one of these things, like including tax production, that's one of the things. Some of the states even offer these incentives. all the way from rebates to even financial support, which is huge because I mean it's just because they want to be more climate friendly and we want to reduce our carbon footprint. And this, of course, this energy uses less carbon and emits less carbon. Um, they just want people to adopt these types of heat pumps. Our last section is called tidal and ocean energy. It just talks about tidal energy and how it's generated through gravitational pull of the Earth, Sun, and Moon. These actually cause these tidal bulges, which um, originate from uh, like the rise and fall of tides. Uh, this one just talks about how mechanical energy is caused by gravitational variations of the moon, of course. The moon's effect is greater than the sun's because of the proximity. Of course, like the moon is closer to us than the sun, even though the sun has a stronger pull overall. Tides actually come from these gravitational forces, and these bulges lead, like they cause high tides every day, which is two a day, and all of this depends on the positioning of the Earth, Moon, and the Sun. This is actually the last diagram I forgot to include on here, but it is here now. But this one is just this one shows the tidal bulges, and I'll zoom in so we can see it. Um, it just talks, and I liked it because it showed how close the moon is right here, and it shows how like this purple outer layer is the tidal bulges, and how I think it's so cool how far out they can actually be. Overall, I liked this chapter, and I learned a lot from it. Thank you so much.